Okay, my name is Ahmed Ubabana, and this is the third screencast assignment for Mr. Morrison's Physics 101 class. So the problem asks the initial velocity of the ball in its first bounce. Okay, so to do this, basically we follow our um, problem-solving method, in which we list the knowns, the unknowns. We identify the physical principle. We draw a picture. We apply the physical principle to a specific equation, and we solve the equation for the unknown, and then we substitute the numerical values to get our answer. Okay, so basically here we have a list of unknowns and a list of unknowns, and basically there for the knowns, we know that the distance of between the two posts shown in the video is 2.7 meters. We know that the acceleration in the y direction is always going to follow that 9.8 meters per second. We know the acceleration in the x direction is 0 because there's no acceleration in the x direction in two-dimensional motion. And we know that the initial position in accordance to the y coordinate is going to be 0 for the initial, and y is also going y final is also going to be 0 because it starts from 0, goes back up, comes back down to 0 along the y dimension. Okay, the physical principle here we're talking about is the physical principle is two-dimensional kinematics dealing with motion. Okay, first steps first, we figure out how many the time frame we're dealing with, and it seems that from the first bounce of the ball to the second bounce, we have 39 frames. The video tells us that the ratio is 1 second per 30 frames. We do the math, we get that the 39 frames is 0.67 seconds. So we have the time, and we can also solve for the average velocity in this problem by knowing the fact that we know the displacement and we know the change in time, which is 2.7 meters divided by 0.67 seconds, gives us the average velocity of 4.03 meters per second. Okay, so basically the problem solving method tells us to apply the physical principle to one of the known equations in which we have in which we can find in which we know all the variables but one unknown. And in this case, y equals, we can use the equation because we're more concerned about because we're concerned about the initial velocity of the ball. We can just be concerned ourselves with the y coordinate, and we say that y equals y initial plus the initial velocity in the y direction times time minus 1 over 2 times gravitational acceleration times t squared. And we know all these variables, but we know all of these variables but one, and that is the initial velocity. Okay, so we set the final displacement as a y equals 0, and the initial y is also 0 in the y dimension, plus the initial velocity, which we don't know, times 0.67 seconds, which is the time which we do know, minus 1 over 2 times 9.8 meters per second times 0.67 squared, which is time squared. And we solve the equation, and eventually when we crunch the numbers, we get that the initial velocity in the y dimension is going to be 3.3 meters per second, and that's what the problem asked for, and that's basically it.